quickly so I can start recording class. And then just, okay, if you needed to get some more information, you can review what we did. Okay, so what we're doing with this one is we're setting up a system of equations. This one actually is simple. Students usually understand this problem very well. This same kind of thing, I test over this same kind of problem because it's a good standard example of a system of equations and two unknowns. Okay, so here's what this problem says. It says that a vendor is selling two things, hot dogs, bags of potato chips. And then there's two sentences. The first sentence says the customer buys 5 hot dogs and 2 bags of potato chips, and that's how much it costs. The second sentence says another customer gets another combination, 3 hot dogs, 5 bags of potato chips, and that's how much it costs. Okay? So when you're setting up a system of equations in here, you want to come up with 2 variables. Okay? You can use X or Y. I recommend that you don't do that. I recommend that you use sensible variable names. So let's say H, and H is going to be the cost. And see, we're trying to find the cost of each item. So H is going to be the cost of 1 hot dog. Okay, so we need to get that kind of established. And then we'll say potato chips, let's say P for potato chips. Okay, so that would be the cost of 1 bag, and it's just 1 bag of the potato chips. Okay, so that's how you want to start the problem. And really the equations are pretty simple on this. Okay, here's kind of the idea. Now you don't need to write this down, just pay attention to it. So let's suppose, I'm just kind of making this up, so let's say that a hot dog costs $1.50. I'm just saying, let's pretend like it does. Let's say a bag of potato chips costs 50 cents. Okay, you could solve this problem by trial and error. Well, the first sentence says you buy 5 hot dogs. So if each hot dog costs $1.50, wouldn't you just do that, multiply and get how much it costs? Okay, then you're buying 2 bags of potato chips. So wouldn't you just take 2 times 50 and then work it out? Okay, well, let's see if we get 1150. If I do, this is an incredibly lucky day for me because that would be an incredibly lucky guess. So let me find out. So let's see, if we go 5 times 150, okay, that would be the cost of the hot dog. So that costs $7.50. Okay, and then you have 2 bags of potato chips, 2 times 50, of course, would be $1. So you would have $7.50 for the hot dogs plus $1. Okay, what do you have? You have $8.50. You were supposed to get $11.50. I could play with this, and do you agree that I could eventually stumble onto the answer? Okay, I could just say maybe a hot dog's $2. Maybe potato chips are 75 cents. It might take a long time, but I could stumble onto the answer. You see what I mean? So what we're going to do is we're going to set up a system of equations. So the system goes like this. Okay, the first equation, you have 5 hot dogs. So that just becomes 5 times H. You have 2 bags of potato chips. So that just becomes 2 times P. You're just multiplying the cost of a hot dog times the 5 that you're buying. So your first equation would then be 5H plus 2P, and that's going to be equal to $11.50. Okay, that's what they add up to. Does that make sense? Tell me if that's a sensible equation to you. Okay, the second equation is exactly the same idea. 3 hot dogs, so what do you say? 3H. 5 bags of potato chips, what's that? 5P. The grand total, that's why you're adding that, is $9.75. So now if we solve that system of equations the way we've been working on with elimination, then we should be able to figure out the answer without trial and error. Okay, so here's what we're going to do on this, and this is the elimination we were working on last class. You make a decision on which variable you want to eliminate. If you want to eliminate the H's, you can do that. If you want to eliminate the P's, you can do that. It doesn't matter. I'm going to make a decision that I'm going to eliminate that. Okay? So watch this thought process on this. Now, if I count by 5s, what's the first number that 2 divides into out of this list? 10. That's what we call least common multiple. So what that means is you would like this to become probably a 10, but that wouldn't want to be 10. That would want to be what? Negative 10. Because if you have a 10 and a negative 10, they're going to cancel. That's the whole process of elimination is what you do. So the thought process on this would go like this. Okay, you can do this in your head, but I'm showing you what I'm thinking. I want 2P to become 10P, so how do I make that happen? multiply by 5, right? Okay. The other thing I want is I want the 5p, right here, I want the 5p to turn into a negative 10p. How do you do that? Multiply by negative 2. So that's the whole thought process you go through. So what we're going to do then is we're going to take the top equation, we're going to multiply both sides by 5. You'll be able to use your calculator on this with the decimals, and then we're going to take the second equation and we're going to multiply it by negative 2. Okay? And once I get past the next step, it'll help you understand why I did what I did. Okay? So do a distributive property. So 5 times 5 is 25h, so you want to write that down. 5 times 2 is 10p. Okay, if you need your calculator on the decimals, you're more than welcome to do that. Okay, so I'm just going to go 11.5 times 5, and I'll record what that is. So that is 57.5. Okay, then I do the same thing with the next equation. Negative 2 times 3 is negative 6h. Negative 2 times 5 is negative 10p. And then again, if I want to use a calculator, I just double the 9.75. Now I am multiplying it by a negative 2, and that'll give a negative answer. So that's negative 19.5. And as you're doing these problems, you always want to keep your system together. Keep them together. Don't lose them, so you kind of keep track of your work. Okay? All right, what do you do now? You just add them together. You add your columns together like this, so I'm just going to kind of draw a line under that. Those cancel. That's why we did what we did. 25 minus 6 is going to be 19h. Okay, then we can take the calculator if we need to and just do 57.5 and subtract the 19.5, and that will give 38. Okay, now what do you do? Divide by 19, right. You got an equation. So you have an equation with one unknown, and if you do that, that's 2. Okay, so h is equal to 2, so what does that mean in this problem? That's how much a hot dog cost, is $2. Okay, so we got that. So when we write our answer, we still got to find the potato chips. We'd write the answer kind of like this, and you would want to say which is which. You would want to say a hot dog costs $2. Okay, so we got that. Okay, all right, any questions so far? Okay, now we got to find the potato chips. Well, here's your choice. You want to go to either original equation. And the best place to go is the original, not way down here, but up in the original. So what I'm going to do for my second step is I now need to find what p is. So I pick an original equation and I write it down. So I'm going to pick the top one, 5h plus 2p equals 11.50. If you pick the second equation, you'll still get the same answer. So that's your choice. So what I'm going to do is I'm going to replace the hot dog's price with 2, and then I'm going to solve the equation. So I just do 5 times 2 plus 2p is equal to $11.50 like that. Okay, solve the equation now. So 5 times 2 is 10. You have 10 plus 5p is equal to $11.50. You can subtract 10 from both sides. So that's 2p equals $1.50. When you do $11.50 minus $10, that's $1.50. You divide by 2, and the result is p is equal to 0.75. So what does that mean? A bag of potato chips costs 75 cents. So we're going to say the potato chips cost 75 cents, and then that will be the answer to the problem. Okay, that's it. Okay, so the next thing I want to show you is how you can tell you're right. Okay, when you do get to the first test, the way I do this is I give you a problem maybe like this, and you get credit for, maybe it's 5 points for solving it. Then I give you half of an extra credit point if you can prove to me that's right. Okay, which part of that is to encourage you to think about your answers, to make sure they're right. That's how you got to learn math, is you got to get an answer and understand why it's right. So let's go ahead and do this checking. So the checking you can do on your calculator. But I'll have you write down what you would do. First of all, the first equation just says you bought 5 hot dogs. So hot dogs now cost $2. Then it said you bought 2 bags of potato chips. So that costs 75 cents. Okay, just work it out, and it's supposed to be $11.50. That's what that sentence said. So this would be $10 plus $1.50 So look what you get. You get 1150. So that's right. But that's not enough. You got two equations, so you got to see if it works on the other one. So the second equation is 3 hot dogs. Okay, every hot dog costs $2. Then it said 5 potato chips, 5 bags of potato chips. So you do that. So 3 times 2 would be $6 there. What would that be? $3.75, right. Okay, so that's $3.75. Use your calculator if you want to. What does that add to? $9.75. That's what it was supposed to do, see? Okay? So see, that's how you understand the problem. Okay? So you can get that idea. See, when you do a system of equations, it takes all the guesswork out of it. I mean, mathematically, it's always going to give you that right answer. Okay? All right, how do you guys feel about that problem? My experience of teaching this, usually students do this well. They usually understand this because you have lots of experience with money. Okay, so that's how it works. If you understand the equations and the process, you should be okay. Any questions? Okay, all right, let's move on to this next one. And we're going to do this one together here. This one's probably a little harder to set up. So let's read this and see kind of what we got going on. So basically, it's the key things is it says there's a total of 40,000 people at a game. Okay, then it's talking about money. So it's basically saying there's 2 types of seats. There's reserved seats, and those reserved seats cost $14 each. So I'm just kind of, as I read the problem, I kind of piece together the given information. Okay, then it says that the general admission tickets, so I'll just kind of abbreviate that, general admission, those are a little cheaper. Those are $4 each like this. Okay, and then it says that based on these tickets that you sold 40,000 tickets. Okay, that's another piece of information. The other piece of information is this is how much money you made. You made $300,000. Okay, that's nice income. All right, so we got that. So we're going to see if we can piece together an equation. Now, anytime you have trouble getting your equations, here's what I recommend you do, because that happens on word problems. Just try to figure it out. Just see if you could figure it out a couple of times with trial and error. I'm not kidding. Okay, so let's just suppose. I'm just grabbing this out of the 40,000. Let's say that you sold 30,000 reserved tickets. Okay, I'm just supposing we did. Okay, well then, how many general admission tickets would you have had to have sold? 10,000. Why? Because you sold that, right? Okay. What if this was 5,000? Then what would that be? 35,000, right? Because they have to add up to 40,000, okay? Now, let's see if we're right, okay? Really, all we got to do is count our money and see if we're right. So what you would do is, okay, you sold 30,000 tickets that cost $14 each. Then you sold 10,000 tickets that cost $4 each. Let's get our calculator and let's see if the teacher's lucky today or not. That's just kind of a wild guess on my part. So let's see, 30,000 times 14 is going to give way too big. Okay, so the teacher's not guessing very good today. So you'd have that, and then if you did 10,000 times 4, that would be $40,000, and then you would add those together, so that adds up to $460,000. What were we trying to make it add up to? 300,000. So see, if you do trial and error, to me, that helps a student begin to understand the problem. Do you guys agree that if I kept changing these numbers, eventually I'd stumble onto it? Okay, so another thing you could do is maybe you could go 15,000 here. Then the way you would figure this out is you would do 40,000 minus the 15,000, which would end up being 25,000. So another possibility would be maybe you sold 15,000 and 25,000. You could check with your calculator and see if you're right. I don't think I'm right, but who knows? Okay, do you guys understand the problem now? Okay, that's important. Now what we're going to do is we're going to set up our system of equations. So what I'm going to do is I'm going to say, come up with variable names. So I'm going to say R is the number of reserved tickets, and just kind of abbreviate that. Okay, then I'm also going to say that G for general admission would be the number of general admission tickets. I try to get students to do sensible variable names and get out of the habit of doing X and Y all the time, because once you solve for R, you're going to know, oh, that's reserved tickets. Okay, see what I mean? So there's a benefit in doing that. So what you got to do is you got to find the connections that we found on this, and this is where it sometimes gets difficult for students. Okay, so let me ask you a question on this. What do R and G add up to?
The number of tickets you sold.
The total number of tickets you sold. What is the total number of tickets?
40,000.
That's an equation right there, okay? You have to see that connection. So R plus G is 40,000. When I was doing this by trial and errors, I was trying to help you understand that. For instance, we did 30,000 and 10,000. That adds up to 40,000. That's the relationship between R and G. Does that make sense? Okay. Now we're going to find the cost. Okay. Well, how do you find how much money you make off of reserve tickets? If they cost $14 each, what do? You do 14R, right? Okay. You just do 14 times R, and that'll give you the amount of money you're bringing in on all those tickets. How about general admission? Those cost $4 each. So what's that going to be? 4G. How much does all that money add up to? That's the other piece of information you were given. 300,000. Okay? So see, that's the system of equations that will solve this problem. You had to figure out that the tickets add up to $40,000, but the money adds up to 300,000. Does that make any sense? Okay? If you stumble with a problem, try to do it by trial and error. Okay? That's the valid mathematical method. It just takes forever. This takes less time. Okay? All right, so now what we're going to do is we're going to eliminate. So it's your decision. We can eliminate the R. If that was a 14R, what would you want that to be? Negative 14R. If that's a 4G, what would you want that to be? And now I'm going to go with the G because it's a smaller number. I like smaller numbers. They're easier to deal with. So what do you need to multiply the top equation by so that G becomes negative 4G? By negative 4, and be careful with the negative on that. Okay, so that's what you're going to do. Okay, now we're going to write this, kind of keep this together. You're doing a distributive property. So negative 4 times R is negative 4R. Negative 4 times G is negative 4G. 40,000 times, and that should be a negative 4 right there. 40,000 times negative 4 is negative 160,000. You could use your calculator if you had to. Now write the second equation underneath it. Don't change it because we don't need to. Okay, so we now have that. Okay, everybody following okay? So now what? Add them together. Okay, you always add. You wanted that to cancel. That's why we did what we did. This is going to add up to 10R. Okay, that's going to be, if you did that on the calculator, I think you would get 140,000. Okay, 300 minus 160 is 140. So then what? Divide by 10. Okay, so what you would get is R equals, that really just divides a 0 out, so that would be 14,000 would be what R is. Okay, all right, so what is the meaning of that 14,000? That means you sold 14,000 reserve tickets, right? Okay, so when we begin to write our answer on this, you want to write your answer like this. You want to say 14,000 reserved tickets, and you can just abbreviate it. I like the students to write it this way. You don't have to, though. At $14 each. That's a good way to write that. $14 each. Okay? So that would be the way to write that. Okay? Now, that leaves us with figuring out how many general admission tickets we sold. So like you can do in any system of equation, the first equation's a lot easier, so what I'm going to do really is just take that 14,000 and plug it in. Then I'll be able to find the number of general admission tickets like that. So what I have is 14,000 plus G is equal to 40,000, like that, and then I can subtract 14,000 from both sides, and you just get your calculator out if you have to. And then we'll have this. So that crosses out. And that is, I think, 26,000. So what does that mean? It means that you sold 26,000 general admission tickets, and those things cost $4 each. So that is the official answer to the problem. That's the way you want to write your answer, is like that. Okay, now we'll check and we'll see if we're right. We'll just do that with a calculator mostly. Okay, is there any question that anybody has on what I'm doing? Does that seem logical, the process I was going through? Okay, now I'm going to go through and just kind of show you how you would check this. Now I'm going to just it's almost like we're doing trial and error again. This is what we just found, and we'll use our calculator to help us. So we had 14,000 reserved tickets, and we had 26,000 general admission. Here's all you got to do to check. You just do 14,000 times 14, and that'll tell you how much money you made off the reserved tickets. Then you need to do 26,000, and you need to multiply that by 4, and that'll give you how much money you made on those tickets. So let's see if we're right on this and see if you understand why we're right. Okay, I hope we are. This is 14,000 times 14. So that means that you are making $196,000 off of those tickets. Okay, then you do 26,000 like this, and then you multiply that by 4. That means that you are making $104,000 off of that. Okay, can you tell me why I'm right? I know I'm right. These two things add up to, look at this. They add up to, they should be 300,000. Okay, you could use your calculator on that if you do that then. Okay, that's what it was supposed to be. So that's the only combination that's possible. All right, you only get one answer on these problems. It's kind of like an intersection point of the graph of those two lines is what it is. Okay, you get one answer. Okay, does that make sense? Okay, do you think that's kind of cool that you can use algebra to indirectly solve something like that? Okay, I think it's kind of cool. Okay, all right, the math, once you find the mathematical relationships, then you get your equations and solve. Okay. Okay, so I'm going to do this next problem we call a mixture problem. And what I typically do on this is I don't want you to write anything down. I want you to, for now, I want you to just pay attention to what I'm doing. And I'm going to kind of set up what the problem means, and then we're going to kind of think through it by trial and error a little bit, and then we'll set up an equation. So what this problem's saying is, somebody who's making metal, that's a metallurgist who is making metal, it says he needs a 20% solution. That's what he's trying to get, and he needs 90 milligrams of this. 20% is whatever that active ingredient is. Okay, but it says he currently has one mixture that's 4% of the active ingredient, and the other one is 40% of the active ingredient, like that. Okay. So instead of metal, let's pretend like this is alcohol, okay? That'll help you a little bit, I think, maybe, I don't know. So here's the idea. Now don't write this out. This is what we need, okay? We need to have two things. We need to have 90 milligrams, and this thing is going to be 20%. Let's just pretend like that's alcohol. Okay, you got 90 milligrams and 20% is alcohol, the other 80% is whatever, okay? Well, what you have is you have these two things, okay? You have a 4% mixture, and you have no idea how much of that you're going to use. Then you also have a 40% mixture. You don't know how much of that you're going to find either. So what you got to do is figure out how much of each of those things you have to do. Now, to help you understand this, there's a couple of things I want you to understand. The reason I want to think about alcohol is think about how mixed drinks go. Okay, say that you got this weak mixture, 4%. What would happen if you poured a 40% alcohol mixture into a 4%? What would happen? It gets stronger, right? Okay. Would it ever become 100% alcohol? Of course not. Would it ever become 41% alcohol? Mathematically impossible. It'll never get stronger than that. What if you did this backwards? What if you poured 4% into 40%? What happens? It dilutes it, right? It gets weaker. Okay, so the idea is if these were like mixed drinks, if you mixed them together, you would end up with something in the middle. And that's what we want. See, that 20% is in the middle of that. Does that make sense? Okay, that's one way to look at that. Now, what I want to look at on here is I'm going to do this by trial and error. Again, I don't want you to write this down. I want you to watch this because this will help you with setting up the system of equations. So I'm just going to take a wild guess. Okay, I'm going to say that let's use 60 milligrams there. That's a wild guess. Okay, can you tell me what would go there? We've got to have 90, so I already got 60, so how much do I need? 30, okay, all right, so you'd have that. So let's say that this is now 30. Now, I'm going to show you if I'm right or not. Okay, it's easy to see if I'm right. Here's what you do. When in your past, you've learned how to take percents of numbers. So if I did 4%, you move the decimal back 2 places to get 0.04, then I'd multiply that by 60. Okay, if I took a calculator if I needed to, what that would end up being, I think, is 2.4 milligrams, okay, is what that would be. So that would mean out of that 60 milligrams, 2.4 is alcohol, or in this case, it's metal, okay? Then I would do 40%, which is 0.40 times 30 milligrams. So that would end up being 12 milligrams like that. That's how much of the active ingredient you have. Then if you go over here, if you did 20% of 90, okay, if you did that, that would end up being 18 milligrams like that. Now, I'm wrong. Do you know why I'm wrong? What do you want in these happen? What do you think the relationship between those 3 numbers needs to be? There you go. These have to add up to that. If they do, then you're right. So I could go through and adjust those numbers over and over again and eventually stumble onto the answer. Okay? So the idea is these 2 numbers right here have to add up to 90. That right there is an equation. And then the second equation has more to do with this, looking at the amounts like that. Okay? So what I'm going to do now, this is what I essentially want you to write down on this. The way I generally teach a mixture problem is I have you go through and just draw, these are buckets, okay, or something. So this is like a bucket. You just use rectangles if you want to. These are going to be the 2 things that you're going to mix. And then you're going to have what you need. Okay, I usually just kind of draw a bigger bucket for what I'm needing. Okay, and it turns out that there's 2 things on this. And this is what you guys need to write down on this then. Okay, all right. So we're going to divide this up into 2 pieces here and kind of do what we did when we were doing it by trial and error. Okay, what we needed was 90 milligrams. That's the amount. And that needed to be 20% of that active ingredient, whatever it is. Okay, like that. Okay, then the problem said we were mixing 4% with 40. And these 2 things right here is what I don't know. So that would be 2 variables. So what I'm going to do on this is just call this X. Then I'm going to call that Y like that. So see, I'm setting it up the same way I did by trial and error. And then ultimately, I got to set up 2 equations with 2 unknowns that would solve the problem. Okay, does that make any sense so far? Now this problem will make perfectly good sense once we finish it and learn how to check our answer. Okay, now I'm going to erase all this stuff because I need to take up a little bit of room on this. Now what we're going to do from here is we're going to build our equations on this. Okay? Can you tell me what the relationship between X, Y, and 90 is in this problem? There you go. They added up to 90, right? Okay, that's what the problem says. Okay? So that means your first equation would be X plus Y is equal to 90. Okay? Now the second equation is doing percentages like I did. So you're going to do 4% of that number. When you do 4%, you have to move that decimal back 2. You got to make sure you have that right. So you would say 0.04 times X, and that would give you the amount of the active ingredient. Then you do the same thing here. You say 0.40 times Y there, and then you got to do the same thing here. You got to say 0.20 times 90. So all you're doing is 4% of X, 40% of Y, adding it together and see if it's 20% of 90 like that, okay? And then you would probably want to go ahead and crunch that out. So if you do 20% of 90, you're going to get 18. Okay, so your system of equations is going to be X plus Y equals 90. And the second equation is going to be 0.04X plus 0.40y is equal to 18. Okay, if you can solve that system of equations, then you'll have the correct answer to the problem. Okay, does that make any sense? Okay, and if it's not quite there yet, it will be once we get done with this, trust me. Okay, so here's what I recommend. Now, if you have decimals in your problem, there's a lot of benefit to making those decimals go away, although you don't have to. This is sort of optional. So it turns out that if you take any number, and you may know this already, if I took a number like, say, like 2.566, and if I multiply it by 100, I want you to notice what happens. What happened to the decimal on that original number when I multiplied it by 100? It went to the right too. That's what always happens. That's what 100 does, is it moves everything over to. Okay? So for that reason, I would like these decimals to go away. So the first thing I'm going to have you do is we're going to multiply both sides of this equation by 100. It just makes, to me, it makes the elimination a little simpler. Now I'm going to just write down the system again. So the first equation, we're not ready to do anything with it. Leave that alone. Okay, now just in your head, you can do the next one. So what's 100 times 0.04? 4. What's times 0.4? 40. 40, the decimal moves over to. Same thing with 18. The decimal moves over to, so it becomes 1800, like that. So by doing that move, you don't have any decimals. And now you start thinking elimination is the best way to do that. Okay, so I can either eliminate y or x. What's your preference?
Looks easier.
Mine's x because it's a smaller number, okay, although it doesn't make any difference. So what do you need to do at the top equation so that the x's cross out? Multiply by -4, right? Okay, you want that to be a -4 there. That's what you want. So that's why you're going to multiply both sides of that top equation by -4. If you do that wrong, you're going to know it in the next step anyway. So this is going to be -4x minus 4y. Okay, this side's going to be -360. Then you're going to write down the second equation directly underneath, like that. And then we're going to be ready to just add everything together. And then we should be able to get, like, whoops, that's not what I meant to do. We'll be ready to get our first answer then. Okay, so let's see, that crosses out. So that's what we wanted to happen. This is 36y. Okay, then I can take, if you need to, you can take 1800 and subtract the 360. So that will give 1440. Okay, then I can divide by 36. And sometimes you'll get decimal answers on this. It actually doesn't matter if you get a decimal. If you get a decimal, just round it. Okay, so that would be y is equal to 40 milligrams. So remember what we're doing is we're figuring out the amount that we needed. Okay, so that would be kind of the first step of the problem, is that you've got that. When you start writing your answer to this problem, you want to kind of write it like this. So basically x, if you look at this diagram I had you draw, x is the amount that's at 4%. So what you would say is 40 milligrams at 4%. You want to write it that way, okay? Now, you can do this in your head if you've caught on to the problem. If you look at this diagram right here, if that's 40, what does that have to be in your head? 50, right? Why? 40 and 50 add up to 90, right? So you can do that step in your head, or you can do this. You could just say x plus y equals 90, replace x, or y was 40. Actually, I got those backwards, don't I? Hold on, let me get this corrected now, okay? Y is what I found. What is y in my diagram? Okay, get that corrected, okay? Be careful. That's the benefit of drawing that diagram, so that you know which is which, okay? So that's going to be the 40 there, and then the other one's going to be the 50. So the thing is, you could plug in that 40 for y, so you'd have x plus 40 equals 90. So if you couldn't do this in your head or didn't know what to do, well, then now you get it. That's equal to 50, okay? So then you would say 50 milligrams at 4%, and that would be how you write the answer to the problem. And now we're going to go through and check it, because that's how you're ultimately going to understand this problem. You know, if you can't check it, then you don't understand the problem, seriously, okay? And that's what I try to get everybody to kind of get to. Okay, is there any question about anything I did in solving the system? That was the algebra part. Okay, now let's check our answer. Let me show you how to do that. Now, what I like to try to get students to do on checking answers is not to plug into your system, but to do this. So this is what I'm going to kind of do to have you check. If you got any room to squeeze it in, just you can kind of go to draw yourself another little diagram, because we know everything now. We know that that X was 50 milligrams, and that was 4%. We also figured that Y was, that was 40, so this was 40 milligrams over here, and that's 40%. And then we were trying to get a mixture that had 90 milligrams of 20%. So it's not enough to just say 50 plus 40 is 90, okay? We know that. That's part of the checking. But the other part, and the important part, is just to calculate the percentages now. So when you do the checking on here, here's what you basically do. You can do this on your calculator. Take 4% of 50, like that. Take 40% of 40, then take 20% of 90, and see if those numbers worked out the way they're supposed to, okay? Use your calculator if needed. So if you did 4% of 50, that would be, I think, 2. Okay, so that is going to be 2 milligrams there. If you did 40% of 40, that would be 16 milligrams. Then if you did 20% of 90, that would be 18 milligrams. So why is it right? 2 plus 16 is 18. Okay, that's why. Isn't that cool? Okay, so that's the perfect mixture. That's the amounts that you have to work with to make that mixture. The whole idea of this is to use mathematics to solve some sort of a problem, whatever it is. Okay, and the system of equations is the best way to do that. Okay, is there any questions? Does that look okay? Okay, all right, because you got to understand these problems and kind of how they set up. So I'm going to kind of have you work a little bit yourself on number 11, but let's kind of go through and work on the setup together. And this is gasohol like this. So the way I always have students start these mixture problems is by drawing a diagram. So let's do this part together. And what you're looking at is the amount goes up there, and then I have you put the percentage in the bottom like that. Now you got to read this carefully now, and you got to know where everything goes. Okay, so it says you got two different gasohol mixtures. One contains 5% alcohol, the other one's 12% alcohol. Now the key word on this problem is obtain. That's what you're trying to get. See, in this diagram, these are the two things you're mixing. This is what you're going to obtain. So let's see if we can fill this out from here then, okay? We're trying to obtain what? 750 gallons. And what percentage does that say? Containing 10% alcohol. That's what it says, right? Look for that word gets, needs, obtains, whatever. That's what you're trying to get. Okay, what are you trying to mix? 5 and 12, right? 5%, 12% like that. Okay, what are your two unknowns? How much you're mixing, right? Okay, so we have that. So that would be what you get. Now I want to have you guys take it from there. I won't tell you anything else. I'll walk around. But a couple of things in your equation. What is the relationship between X, Y, and 750? They add up. So what's the equation? X plus Y equals 750. Then you've got the percentages, remember? So you say 5% of X plus 12% of Y equals 10% of 750. Now take it from there and see what you can do. Okay, the rest of it's algebra. And when you get an answer, try to check it. If you get a decimal, just round it to like maybe 2 decimals. I'd usually say if you get decimals, which you do sometime, use 2 decimals, then when you check it, you'll be close, but you won't be perfect. Okay? Then I'm going to cut this off. Does everybody have that copy down, or is anybody still doing what you need there? Because I'm going to shut the screen off. While you're working it, I'm going to work it out. And you guys can work together. If you're having some trouble, help each other out a little bit and see if you're on the right track, okay? And I'll work it out, and then I'll come around and see if you're on the right track. So you are going to get decimals. That's what I thought. Okay, round your answer to 2 decimals. You'll have 2 answers, round each to 2 decimals. Okay, I'll walk around a little bit and see if we're on the right track. We're setting it up and see kind of how we're doing. Okay, got a good system. Okay, now that's 5%. Be sure you use 0.05.
Oh,
Let's see, 50% is 0.5.
yeah, you're right.
Do that. Okay? Like, no, then you can multiply by 100 to move the decimals over, then start trying to eliminate it. Be sure you use 0.05 for 5%, not 0.5. That's just going to do it all. Just common mistake. Is that what you did? Sure, okay. You got everything worked out pretty good. Yeah, you got to use 0.05. Decimal has to move back too. If you do 0.5, you're going to 50. Well, then, yeah. There you go. Oh, man, beautiful. That goes well. Oh, it's right, just a tad bit. I think that was a, see, you forgot to do this. You have to do 10% of 750. And if you do 10% of 750, that whole thing becomes 75. So that second equation, 0.05x plus 0.12y equals 75. So you didn't do the 10% of that, you just did 10%. You got a percent, you got to do it of something. So you want to adjust that a little bit. I can tell you're on the right track with what you're doing, but you need to go back and adjust that, and then this would be your system that you solve and see if you make a check. Because it looks like you know mechanically how to do that. That's what I got. Okay. Yeah, so push on and see if it's right, see if you know how to check your answer. Okay. Okay, so that's a good first equation. Okay, you did that, you got three decimals. And see what you did? When you multiply that by -5, which is exactly what I did, you forgot to multiply 750 by -5. That's it. That's a minor mistake, so that's not bad. So go ahead and fix that again. Okay, I see one little mistake there. -5 plus 12 is 7y. Right, okay. And then do that again. Use your calculator if you have to. 7,500 minus 3,750. Then you're going to be able to get it okay. Careful that around, okay, your first equation's good. The second one now, you don't, that you're doing 10%. Yep, because that's what it said. Remember, that was 10% of 750. So you're doing 5% of x, which is correct. 12% of y, that's correct. 10% of 750. Okay. So what you'd want to do is write your system like this. Your first equation's good. The second equation, you would have 0.05x plus 0.12y like you have, and then if you do 10% of 750, you get 75. And then if you kind of look at what I was doing, I multiplied the second by 100 to get rid of decimals, then tried to eliminate it from there. Right? And that's how it works out. Right? You got a negative answer.
Yeah, I got one too.
So you're redoing it here. Yeah, you're right now. Okay. Well, see what I would do on that. When you do 10% of 750, you get 75. So right now you don't need that. Your first equation would just be like x plus y equals 750. Your second equation before you get rid of decimals is going to be this. Let's see, when you do 10% of 750, you get 75. Now you want to clear the decimals and then eliminate. See what I mean? That's the one. That's a mistake students make all the time. You got what I got. Now you know how to check it. Got a way of trying to get blood vessels out there. A little bit of arithmetic and so okay, see the equation would go 0.05 times x plus 0.12 times y equals 0.10 times 750. The second equation you're doing, you always have to do a percent of something, so 0.05x, 0.12y equals, and when you do 10% of 750, you get 75. That is your top, that's your first equation. Your second equation is this. Now you need to just see if you eliminate. Yeah, you just didn't quite have that piece right. You're missing this right here. No, you're okay, I think. So what I would do is you got your first equation right. The second equation, you just need to work that out. So you would have like 0.05x plus 0.12y like you have, but then when you do 10% of that, you get 75. And I see that you've got that. I'm a little afraid that you're going to mess up though when you get rid of the decimals. So now what you want to do is multiply both sides of this by 100 because you're trying to move the decimals over in two places. So you want that to become 5 and you want that to become 12.
You can take it from there and see what you get. That's what's wrong right there. So see, when you multiply by 100, that would end up becoming 75 to 100. Yeah, because see, when you do 10% of 750, 10% of 750 is going to be 75. But then when you multiply by 100, that's going to turn into 5, 12, 7,500. Okay, then you got to put that together. You got to do these things step by step carefully. You're going to mess it up. That's good. You got it. Okay, good. Not this one. Do that again. I think you missed a decimal on there. Okay, but don't do substitution, do elimination, it's easy. So when you do this, that second equation, you're going to have 0.12 plus 0.05 equals 10% of 750 like that. So your first equation, of course, you got right, so it's x plus y is 750. Second one would be 0.12x plus 0.05y. And then when you do 10% of 750, you get 75. So if you took your calculator, 0.10 times 750. Then if you multiply both sides of this by 100, you would get this system. X plus y equals 750, 12x, okay, plus 5y equals 7,500. Okay, then that's where you take this from here. Eliminate. You want the y to eliminate, multiply the top by 5. Okay. Let's work on that a little bit. I'll put it up here on the board here in just a second. Okay, so here's what you should have got. You should have got 535.71 for the 12%, and you should have got 214.29 at the 5%. Okay, if you got that right, that's what I'd be looking for. And I'm going to put this up here in just a minute. And there's two places where I see a lot of students making mistakes, so I want to see if I can get that correct. I'll put it up here in just a second. You got it okay? You got everything okay? Right? There's two places where you got to be careful. So let me kind of help you with this, and then we almost got it. Let's cover this and we'll take a break. So, okay, let me go over a couple of things. Okay, first of all, the first mistake that a lot of you made was this. Okay, this is common. 5% is 0.05, right? Not 0.5. Does everybody understand that? 50% is half. That's 0.5. Okay, so you got to have that. All right. Here's where a lot of you messed up. See, when you do the second equation, you're doing 0.05 times x plus 0.12 times y. Then you're doing 0.10 times 750. Go ahead and do it. Okay, I see students don't do that, and it messes them up when they get rid of the decimal. So the system you're going to work out, really that second equation is 0.05, 0.12, y equals 75. Do that. If you got to do a percent, do it. Okay. Now I want you to kind of see what I did here. I multiplied by 100. So that second equation is going to become 5x plus 12y equals 7,500 now. Okay. Then I'm ready to eliminate. So if I have the second equation's 5x plus 12y equals 7,500, I multiplied by -5, which is what most of you did. So that top equation becomes -5x minus 5y. You got to multiply that out to get the -3750. Okay. Now once you get to that point, you're going to get the right answer. Okay. So ultimately, if you did the work this way, that cancels. That's 7y. That's 3750. Divide by 7. Use your calculator. That's what you get. So that's what you should have got when you did that. And then you don't really these two things add up to 750. So what I did, just to get the other answers, I do this. Okay, I just take 750 and subtract that first answer, which would be 535.71, and that gives the other answer. Okay, 214.29. Okay. All right. So is there any questions? Now I'm going to check this, and then we'll take a break. So if you didn't check, you need to know how to check this. Okay. So watch how I do the checking. What I actually do on the checking is I'm going to erase some of this just for now. But I'm going to go back. Now I know the answer. So I know this first answer, x was 214.29. Okay, the second answer was y was 535.71. Okay, this is all you got to do to check is just do this. Do this percentage. That would be 0.05 times 214.29, and we'll kind of do these on the calculator as we get them. So if I do 5% of this first answer, I'll record what I get. Okay, and I'll maybe round this to like 2 decimals again, so I think I'll just do all the decimals on here, 0.7145 like that. That's how much active ingredient is in that mixture. Then if I do 12% of 535.71, which I can do on my calculator, let's see what that is, 535.71. Okay, that's going to give 64.2852. Okay, now the final thing that I got to check is what's 10% of 750. Okay, well that's 75. Okay, why is this right? You didn't kind of reason this out in your head. Why is it right? Because they add up to 75. They're close. 64 and 10 is 74, but that's going to be real close to 75. So you're right. Okay, how's that look? Most of you just did a few little arithmetic mistakes on that system. So it's not that hard to do once you get the hang of setting it up and doing the system then. So I teach you a different strategy on this, okay? Okay, so first of all, when I read this problem, this says you have an aircraft that can fly 912 miles with the wind in 3 hours. With the wind, what does that mean is happening? The wind is kind of helping the plane along. It's sort of pushing it. So pilots, I guess, do that some. Maybe they get up in the jet stream and to kind of, it'll push them a little bit so their engines don't work harder. Okay, then it says you can go the same distance, but this time it's against the wind. So the plane's working against the wind, and it takes longer to get to the destination as a result. Okay, so the first thing that I like to show students how to do on this problem is set up a chart of information. So you need to go ahead and start this problem by setting up a chart. Remember, we're looking for 2 equations with 2 unknowns. The 2 situations is you're going with the wind, and then the second one, what you're doing is you're going against the wind like that. And there's a relationship that you've probably have learned in the past. There's a simple formula that says the distance is equal to the rate times the time. So you're going to make a column for distance, a column for rate, and a column for time, and that's how you're going to build your equations then, okay? All right, so let's go ahead and let's put in kind of what we have on this then, and watch carefully how I put this in. So that's step 1, is get everything put in. So the first thing is when it's talking about with the wind, it gives you 2 pieces of information. 912 miles is a distance, so put it in. What's 3 hours? That's a time, so you want to put that in, okay, like that. All right, now we want to move on, and then the next thing it says against the wind, it says same distance. So what's that? 912 again. What's the 8 hours? That's a time. That's all you're given in that problem is this. That's not enough. Now you got 2 unknowns. So what we're going to do on this is let's kind of do this like this. We're going to find, ultimately we're going to find the speed of the wind, but I'm also going to have you find the speed of the plane. So let's do this. Let's let P be the speed of the plane. Okay, so we want to get that put together, okay? And then we want to use a sensible variable like W is going to be the speed of the wind, like that, okay? Now we got to have variables. It's the rates that are unknown, and both of them are unknown, okay? All right, so let's see if this makes any sense, okay? All right, I'm the plane. The wind is making me go faster. So what would you do with P and W, you think? If W makes P go faster, what do? You add them, right? P plus W. You take the speed of the plane and you add the speed of the wind. That's making you go faster, okay? Does that make sense? Okay, what if you're going against the wind? What's happening to the plane? Slowing down. So what do you think you do? Subtract? Is that what I'm hearing? Okay. Which way? P minus W or W minus P? It makes a difference what order you do that in. What do you want to be faster, the plane or the wind? You want the plane, okay. If you did it this way, the plane would crash, okay. The wind's going faster in the plane, but it would you'd get crazy answers. So this one is going to be P minus W, like that. Plane slows down, so it's subtracting off the speed of the wind, okay. So that's your table. That's how you start the problem off. Now the next thing is you want to go ahead and you want to get your equations. So that's the first thing you want to do, then your equations. Now the nice thing about the equations, they're staring you right in the face. It's just distance equals rate times time. So that first equation is 912 is equal to the rate, and that has to be in parentheses, times the time, so that's 3 like that. Okay, that's equation number 1. Equation number 2 is going to be distance, 912, equals rate, which is the whole thing P minus W, times the rate 8 like that. Okay, that's your system of equations right there. Now, you got 2 choices from here. The first choice is you could go distribute and get 3P plus 3W equals 912. That's good. You can do it that way if you want to. 8P minus 8W equals 912. Now, here's what I tell students to do. Okay, because this happens sometimes on these problems. So what I do, if I took a calculator, the other thing I could do is I could divide by both sides of this equation by 3. So notice if I did 912 and divided by 3, I get a whole number, okay? And then if I do 912 and divide it by 8, I also get a whole number. So that's the way I'm going to approach it. If I would have got decimals, then I would probably just distribute and get 3P plus 3W. And you can do it that way if you want to. I don't care. This is just a little simpler if we do it this way. So what I'm going to have you do is let's divide both sides by 3 there. Okay, and let's write down the result of what we get here. Okay, so let's see, I did that on my calculator. 912 over 3 was 304. So this system now becomes 304 equals P plus W. Okay, like that. Okay, because that cancels out. Then we do the division. Now you go to the next one. You can divide by 8. That's a valid thing to do to both sides of an equation. So when I do that, 912 divided by 8 was 114. So you have 114. 8's cross out, equals P minus W, like that. Okay, does that make sense what I'm doing? Okay, once you build that chart, the equations are staring you in the face. This equals this times this, because distance is rate times time. That's the formula that relates distance and rate and time. So what we're going to do now is we're going to solve the system of equations. So our system is 304, it doesn't matter what side you put stuff on, is equal to P plus W. 114 is equal to P minus W. Okay? How about elimination? Doesn't this look like really just a super nice elimination problem?
No, never mind.
Yeah, look at that. They already canceled. So take advantage of that. Okay? You can just add those 2 equations together and then you're going to get the speed of the plane. So what I'm going to do here is this side, that's going to cancel. P plus P is 2P, not P to the second. I get that from students all the time. 1 plus 1's 2. Okay, then you add this up, and that would be, what's that, 418. Okay, then you can divide by 2. So if you divide by 2, you get the speed of the plane is 209 whatever. I guess it would be, does it say, yeah, miles per hour is what that would be. Because
This may sound like a dumb question. Where did the 2 people come from?
What's that?
Oh, wait, never mind. It's on
1 plus 1.
Yeah, it's on
That's okay.
Sorry, okay.
No, I see mistakes on that all the time. That's common. Okay, so that would be the speed of the plane right there. Okay, all right, so that's what you do. Now what you got to do, kind of the third thing you got to do is now you got to find the speed of the wind. So we got to find the wind speed. So what you always do on that is you just go back to the system. Now you could go way back to the beginning, or you could just go back to one of these 2 right here. To me, I'd be inclined to just go with 304 equals P plus W. So that's what I'm going to do, is let's write down this equation. You just go back to one of the equations of your system, you take your pick, and now we know the speed of the plane was 209, right? So what I'm going to do is I'm going to solve this equation. 304 is equal to 209 plus W. Okay, that's an easy equation to solve, so now you can subtract 209 from both sides. And if you do that, you would get the speed of the wind. So what's that? 95? Yeah, okay, so that's 95 miles per hour there, so that's the speed of the wind. Then we're going to look at checking, because I want you guys to know how to check this and make sense out of the problem. Okay, so the plane's going 209, and that would be the speed if there wasn't any wind at all, but then the speed of the wind's 95, like that. Now see, that system right there is easy. It's already eliminates, so that's not nearly as hard as the ones we just did. Okay, is there any question about that? Okay, let me show you how I want you to learn how to check this. Okay, you're tested on this, you learn to do this. Okay, we got, just redraw your chart because now you're going to know everything. Okay, this is going to be with the wind, this is going to be against the wind, with and against. So we have distance equals rate times time, and we know everything now. We really do. Okay, so what we have is we have 912 here, and we had 3 there. In the beginning of the problem, that's what we had. You're also given against the wind, 912, takes 8 hours. Okay? Now, what goes here is going to be P plus W. You're taking the speed of the plane, and you're going to add that to the speed of the wind. So if you take 209 plus 95, if you do that, what's that, 300?
304.
Yeah, 304. Okay. So I'm going to put a 304 there. Okay, that's what you get there. Okay, that's with the wind. Now, if you go against the wind, what did we say we were doing? We said we take the speed of the plane, and to slow down the plane, what did we do? We subtract it, right? Okay, so you want to do that. So 9 minus 4 is 5, or no, 9 minus 5 is 4. Okay, and then that one you would have what, 100 and, what is that? 104, yeah, okay. All right, so this one you're doing P minus W, like this. So P minus W gives you 104 like that. Okay, now you can get your calculator, and I'll show you how you can tell you're right. That's very easy.
114.
What's that?
It's 114.
Oh, 114, sorry. Yeah, you're right. Okay, I would have caught that anyway here. Okay, all right, how would I tell them right? Well, the thing is, what is a distance? It's what? Rate times time. So if you take 304 times 3, it better give that. How about this? You do 114 times 8, see if it works. Because you're doing distance equals rate times time. So really all you got to do on this now is just, and you can do this in your head if you want to, if you can see that. 304 times 3 is 912. Whoa, I did the wrong thing. 304 times 3 is 912. That works. And then I do the second one, 114 times 8 is also 912. So I'm right. Does that make sense? Okay, they're all checkable. Everything that you do here is checkable and verifiable. Okay? Any questions? Okay, all right. Now I'm going to kind of help you guys set this one up, and then I'll have you finish it up. So again, when you do this when you do these problems that have distance, rate, and time, the way that you want to start after you read the word problem is get you a chart set up. Okay, and this one's very similar to the problem I just did. So this one says that a boat's going downstream in 4 hours. 36 miles, 4 hours. Downstream is just like the same thing as with the wind. Same concept. Then it says it returns, it does a return trip upstream in 6 hours. That's no different than going like against the wind, like the plane. It's analogous to that. So what we're going to do is the two things we have going on is we got downstream, which kind of makes the boat go faster. The current's making it go faster. And then you're going upstream, which means the boat's going to go slower. The current's going to cause it to go slower. Okay, then you just do distance equals rate times time, and then you fill in the blanks there. Okay, so if you look at this piece of information right there, this tells you this. It tells you that you travel a distance of 36 miles in a time of 4 hours. That's what that statement says. Okay, then it says you return in 6 hours. Okay, what's the distance going to be on the return?
Still 36.
It's got to be the same, okay? You're assuming that you're making the same trip. You're going down and you're turning around and going back. Okay, so that's what that is. Now, what they say in this problem is they say let x be the speed of the boat. Okay, and then they say y is the speed of the current. Okay, like that. Okay, so it's the same idea. When you're going downstream, how is y the speed? How is the speed of the current going to affect the speed of the boat? Makes it go faster. So what are you going to do with x and y? You're going to say x plus y. Okay, that makes it go faster. When you're going against the current, what's the boat doing? It's slowing down. So what are you going to do with x and y? Subtract. Which way? X minus y or y minus x? Boat must be faster, right? Okay, you get a ridiculous answer if you do y minus x, okay? Kind of like on the plane. So that goes x minus y like that. All right, does that make sense? Okay, set up your equation now. Let's go ahead and set it up, and I'll let you finish it up. So the equation on the first row is going to be distance, 36, equals rate times time. Okay, second equation is going to be 36 distance equals x minus y times 6 like that. Now take it from there. One thing that you want to notice on this, then you have two choices. You could say 4x plus 4y equals 36. You could say 6x minus 6y equals 36. Or you could divide by 4 and divide by 6. Your choice. I don't care. Whichever way you think's easier. So go ahead and take it from there then. See if which way is better. You can go through and get 4x plus 4y is 36 if you choose. But if you see that it's a little simpler, go this route. This is what you should do. This is easier. So 36 divided by 4 is 9. The 4's cross out. You have x plus y. That's a simpler equation, right? And you can do that. Okay, now go through and divide by 6. And then notice what you have here is 36 divided by 6 is 6. 6 is cross out, and you have that system. Wouldn't you rather do it that way? Because what happens when you add those equations together? The y's cross out, okay? That's why you do it that way. Okay, so 9 plus 6 is 15. Y's cross out. X plus x is 2x. Now, if you divide by 2, you're going to end up getting x is equal to 7.5. So what that means is the speed of the boat would be 7.5 miles per hour. Okay, so we got that answer right there. Okay, does that look good? Okay, now if you want to find what y is, well, just pick one of these equations in the system. Doesn't matter, you'll get the same answer. I'm going to pick the top one, so if I do 9 is equal to x plus y, and I know that x is 7.5, you can almost do this in your head. So that would be 9 equals 7.5 plus y. Then you can subtract 7.5 from both sides. And then you'll end up getting 1.5 is equal to y. Okay, so the speed of the current's 1.5 miles per hour, like that problem done. Okay, you see what I mean? So if you take advantage of the fact that you could divide by 4 and divide by 6, then it works a little faster for you. Otherwise, you'll get the same answer, but it just takes a little bit longer to do. Now, let me show you real quickly how this checking would go, and then we're going to start something a little new here. So when you check, the way I like to see students check is just do this, and you'll be able to do this on future tests. You have the down and the up. I just say redraw a chart, and now we're going to officially know everything. We really do, okay? So downstream the trip was 36 miles. That was given in the problem. The time it took was 4 hours. That was given in the problem. Okay, upstream, same trip. That was given. It took 6 hours because upstream's going to probably take longer. Okay, all right. So what we said is if you go downstream, you're going faster. So that means that you take these speeds and do what to them? You add them. So if you do 7.5 plus 1.5, that means that rate is 9. Can you already tell it's right?
Distance equals rate times time. 9 times 4 is 36. Okay, see what I mean? Okay. The next one, when you go downstream, what do? You take the boat and you make it go slower. So if you do that, you get 6. That's it. 6 times 6 is 36. 9 times 4 is 36, so that means you're right. Okay, how's that look? Is that sensible? Okay. All right, any questions about that then? That'll close us off then. Let me stop this then, and then we'll